we are going to look at the Leetcode problem, substring with concatenation of all words. So you are given a string yes and an array of strings words. All the strings of words are of the same length. A concatenated string is a string that exactly contains all the strings of any permutation of words concatenated. For example, if words contain the strings the word A, B, C, D, and E, F, then A, B, C, D, E, F, A, B, E, F, C, D, C, D, A, B, E, F, C, D, A, F, E, B, E, F, A, B, E, F, A, B, C, D, and E, F, C, D, A, B. All these are going to be all are concatenated strings, and A, C, D, B, E, F is not a concatenated string because it is not the concatenation of any permutation of words. And we are going to return an array of the starting indices of all the concatenated substrings in yes, and we can return the answer in any order. Example, yes is bar foo, the foo bar man, and words contains foo and bar. So we are going to look for foo bar or bar foo in this string. So here we have starting at index 0 we have bar foo, and then starting at index 9 we have foo bar, and so the output would be 0 and 9. Second example, the yes is gonna be word good, 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 best word. So we want to look at the string word good best word starting at any indexes, but we couldn't find it. So the output is going to be null here, and here we want to find bar foo the or foo the bar or the bar foo, any of those, and we have it starting at 6 index 6 we have foo the bar, foo bar the. Yes, that's a valid one, even though it goes like this, foo bar the. And starting at index 9 we have bar the foo, okay, and starting at index 12 we have the foo bar. Yes, that's a valid one too. So the output is gonna be 6 9 12. So let's start coding here. So first we need to initialize a result list to return the result. Result is going to be a list of integer to store the starting indexes of the concatenated strings. So now we are going to have frequency map of original words. Yeah, here we are filling the word map with word frequencies, and the next step is going to be we are going to try all the starting points within a word length window. So let me write the pseudocode here. Now here we are going to try all the starting points within a word length window. So that is like for offset in 0 to word length -1, we are gonna say left is going to be offset and right is going to be offset, and scene is equal to, we need to define scene. It's going to be a hash map to store how many times we have seen a word. And here after that, in step 4, after this we are going to slide the window across, yes, in word length chunks. So that means while right plus word length we are going to say word is going to be s dot substring right And then now suppose let's say case A, we have word is a part of the words list. If word in word map, then we have case A2. Here let's say case A1. Here word appears more than allowed. Scene of word is greater than word map of word, then we are going to say left word is equal to yes dot substring case A2 is going to be valid window found. So if right minus left is equal to window size, then we are going to add left to the result. Case B, word not in words list. So we are going to say else clear scene and left is equal to right. And then we are going to return all the collected indexes here. Okay, now I'm going to code here. So we are going to use the optimized sliding window approach with offsets. So here we are going to try all the possible starting offsets. So we can use for loop and to try all the possible starting offsets. We are gonna start from 0. Offset is equal to 0 and offset is less than word's length. Offset plus plus. And left and right, they both are going to be the offset, so we can just say that here int left is going to start with offset which is 0, starting of the string, and right is also going to start with the beginning of the string. And then we are going to have the scene hash map, which is going to be map, which is going to have a string and an integer. Now while next we have this one. While right, we are gonna make sure we're gonna slide the window across, yes, in the word length chunks. So word length is like, so we are gonna say right plus word length, because right, the offset is going to begin with the 0, and we are gonna say right plus word length, so that would be the length of the window. If it is less than or equal to s dot length, yes, it should be less than or equal to the string's length. We need to make sure of that. And so we're going to say word is equal to, we're going to take the substring that's going to start with from the right, which is the beginning 0 here, and right plus word length, which is going to be 3. So we are going to move in the slide the window across the s in word length chunks. And so now let's say word is equal to substring of right comma right plus word length, and then we are going to increment the right pointer. Right plus is equal to, it's going to be incremented in word length. Here the word length is 3, so every time it's going to be like 0, 3, 6, like that. Then we have this one, KC What happens if the word is a part of a word list? We got the word, which is the 3-character string here in this case, because the word length is 3, and now we need to make sure it is now we are checking if it is a part of the words list. So for that we are going to say if word map dot contains word, okay, then we are going to say scene dot put word comma scene dot get or default Okay, here it's going to we would get the number of times, number of frequencies a particular word is in the scene hash map, and if the word is not there, the default is going to be 0, and we are going to add 1 every time and then we are going to put it into the scene hash map, and yeah, it should be contains key, because key is the character, not the character, the word, and the value is going to be the integer, so it's going to be contains key. And so now we need to shrink the window if the word seen too many times. Okay, what happens if the word appears more than allowed? We need to check that. So for that we are going to say while scene dot get word is greater than word map dot get word, string of left word is going to be substring, left comma left plus word length. Yeah, here we have -1, so that's how we shrink it. And left, we are going to increment the left again by word length, which is 3 in this case, in the first example. And case A2 is a valid window found. So what are we going to do? If a valid window is found, we are going to store the index. So now we have this case B here, which is reset if word is not in the list. So we are going to do this if count is equal to, we're gonna say, yeah, word count result dot add left, and in the else block we are gonna say scene dot clear because we are resetting if the word is not in the list, and count is gonna be 0, and left is going to be right, and left and right are going to be same, and here we're going to return the result. Okay, I'm thinking that this should work. Yeah, actually here this is a typo there. Again another typo. Yes, this worked. And here we have this one. That's good. Okay, that's good. Now we are going to have an example walkthrough. Now let's look at an example walkthrough. And before that, I would like to say that the time complexity here is going to be O of L multiplied by N minus L multiplied by M, where L is the word length and N is going to be the length of the string N, and N of length of the string S, and M is going to be the number of words, and the space complexity is going to be O of M multiplied by L for hash maps. So now let's